Good morning. It's a great privilege to be with you here today. And unfortunately, I need to start my presentation by making an apology, which is the fact that I'm going to have to use the C word repeatedly this morning. And as you know, the C word, if we can get it, is the cloud. And this word gets used so often today that sometimes I think it's been stripped of all meaning. There's an extraordinary amount of hype around it. And unfortunately, I belong to an industry that every decade or so we like to breathlessly announce that we've rediscovered something. And I've had a lot of people say to me, this cloud thing, is this just time-sharing rediscovered? And in a narrow sense, it is. But actually, I think it can be used as a label for things more profound. And I'm going to use the word this morning really as a label for a new era of computing, and I'm going to try and explain why, after 30-plus years in this industry, I do think we are on the threshold of a fundamental new era. And the reason for that is that what we're really seeing play out in front of us is the next major round of the interaction between classic IT on the one hand and change that's being driven out of the consumer world. And this is the second major round where we've seen this play out, and I'll cover that in just a second. It's about many forces acting together. And often cloud, I think, is associated with where the computing is going to be done, but the profound changes actually are more about how the computing is going to be done. So when I talk about cloud today, I'm going to be talking about how, not so much about where. This will redefine our IT over the coming decades and pose a challenge to us. Because every time one of these new eras comes across, the challenge is how do we make the transition? How do we manage our existing investments in our current technologies, which we cannot walk away from, and yet free up the funds to really tackle the new opportunities that come out of this new era? And this is a common theme that both industry and government faces. I meet probably on a weekly basis with leaders out of industry, and when you meet with people at the CEO and CFO level, they express frustration because they see approximately 2/3 of their IT budget today going on things that are fundamentally undifferentiating, things that don't necessarily make them the better bank than the next bank or a better retail organization than the next retail organization, and they know they cannot increase their overall IT spend. What they want to see is that ratio inverted, going from spending 2/3 on things that are non-differentiating to spending 2/3 on things that are fundamentally differentiating in their industry. And this is crucially important today, as I'll illustrate, I hope, in a couple of minutes, because too many businesses in the world are sitting on an application infrastructure that was written for a world that was fundamentally non-real-time, a world of paper bills. And those businesses are not going to be able to service the Facebook generation who expect to see information in real time in the context that it's appropriate without a fundamental renewing not just of the underlying IT infrastructure but of the applications themselves. So we face a crucial issue of how do we become fundamentally more efficient in our existing operations in order to free up the funds for the future. Now, I said that we're seeing the second iteration of the interaction between enterprise IT and the consumer world. The first era of IT that people like to talk about was the minicomputer and mainframe era. This is the era that I was born in. I started, I'm old enough to say that, I started my working career in 1978, and I hoped to work on very sophisticated stuff on compilers and operating systems. Instead, I got my first job at a company called Burroughs, which some of you may even remember. And just to put me in my place, they gave me my first job, which was to debug the firmware in a 12-bit microprocessor that was controlling the printer in the world's first ATM machine. And I was deeply insulted by that, but in many ways, it set me up for the future that I'll come back to in a second. Each era is defined by a set of canonical applications. The applications that defined the mini-computer and mainframe era were really bookkeeping applications. How did we take bookkeeping functions and automate that? And that gave rise to not just the systems we had, but the application technologies, the data fabrics. And then something happened, which was the client-server area, which was the first interaction for the first time of consumer-driven technology coming into the IT world. We went from PCs that introduced, as you'll see in a moment, new technologies in both silicon and software. That was then accentuated by the web, a great example actually of the defense community giving back technology to the consumer world, because those of you who are also old enough to remember that the mainframe era was hell-bent on going down the SNA route, which was a paradigm of a centrally controlled network that was supposedly much more efficient. And the defense community realized that to have something resilient in the battlefield, we needed a network that was not centrally controlled and was fundamentally able to heal itself, which was perfect technology to match the chaotic nature of the internet and allow it to grow in an orderly way. And those technologies really, for the first time, dramatically increased the scale that we had to deal with. Now we had hundreds of millions of users, up from a few millions, mainly sitting behind personal computers. And out of that, we got these new technologies, the graphical user interface. We got new development paradigms. That's where the Java language, for instance, got born and introduced into IT. We got new silicon standards like the x86 microprocessor. And the client-server era was enabled, most importantly, by a change in the underlying data fabrics. We couldn't have built these canonical applications without the relational database. So the canonical applications of the client-server area were the first emergence of the truly integrated ERP systems, of e-commerce, of analytics. And those were really enabled by and drove a fundamental change in the underlying data fabric. We went away from ISAMs and other technologies onto the relational database. As you'll see in a moment, we're seeing a similar shift emerging in the new era as the data fabrics change as well. Out of the web area, we got an additional set of technologies, IP networking I mentioned, new development paradigms. We got HTML as a way of projecting the user interface. Now we're going into the third era. And the key thing here is we're going from hundreds of millions of users to billions of users. And it's not just personal computers that they're holding in their hands. 3 years ago, approximately 90% plus of all devices attached to the internet were personal computers. Sometime in the near future, and depending whose numbers you believe, it might actually happen in the next 12 months, 50% or more of the devices attached to the internet will not be PCs. And within 3 years, PCs will probably be less than 20% of the devices attached to the internet. And it'll not only be devices that have a human attached to them, but also sensor devices that are feeding information in unprecedented quantities. So we're going to see enormous growth in scale. Scale not only in terms of the number of users, but scale in terms of the number of sources of potential real-time information. This is going to drive similar change. I've already mentioned scale. A lot of the new technologies are coming out of the consumer operations like Facebook, Twitter, who've had to deal with scale that the enterprise to date hasn't had to deal with. Facebook has to deal with now approaching 800 million users. out of their operations. They cannot do that on the same infrastructure that we use in the enterprise today. So we are starting to see new technologies emerge to do that, and I'll come back and touch on these. They also have a need for efficiency that has not been seen in the internet, sorry, in the enterprise. A couple of years ago, we hired two gentlemen, very experienced gentlemen out of Google who'd been running all of Google's internal infrastructure, and we put them to work on a project that I'll mention in a second. And about 9 months ago, it occurred to me to go and ask them how many system administrators Google has for their 1.3 million physical servers. And so I called up, emailed Mark and said, Mark, how many system admins do you think they have? And there was this debate, and what is a system admin and who is a system admin, et cetera. And they went backwards and forwards and mailed some of their buddies. And eventually they came back with an estimate of probably about 1 per 1,000 physical servers. Of course, I then took that information and turned immediately around to our own internal CIO, Mark Egan, who must have the world's most thankless job with the amount of free advice that he gets, and said, Mark, how many, we're not a particularly complicated company, how many admins do we have internally at VMware for our physical servers? It turns out we're probably, if we're generously defining it, about 1 per 50, an order of magnitude difference. This is the kind of change that we're going to have to confront. As you'll see in a moment, we can't free up the funds for the future unless we set those standards of efficiency that we have to reach. And those efficiencies are being pioneered now in the consumer environment. Now, it's unfair to compare Google. They have a limited set of applications. They've been written custom for that environment, et cetera. So it's not an apples-to-apples comparison, but the point nevertheless remains. We have to hold up a fundamentally quantum jump in the amount of efficiency that we have to achieve in our internal operations. New development paradigms are emerging. I'll come back and touch on this. If you look at what programmers under the age of 35 are doing, they're not doing what their fathers are doing. They're doing something different. In the last 5 to 8 years, it's been very interesting to see a programmer-led revolt against complexity, where they've taken things into their own hands and are charting a new course forward. And lastly, these new data fabrics. You cannot build Facebook on a relational database. Simply cannot be done. The amount of scale that you need means that you have to adopt a scale-out rather than a scale-up architecture. And that's what's going to be needed as we go into the canonical applications of the cloud era, which I believe are going to be real-time analytics. Businesses want to no longer just have the facility to capture information, put that information into a giant warehouse, let it lie fallow for a month or 3, and then run some reports to find out what happened in the past. Businesses want to react to what people are doing in the present. We have great examples of this. I was mentioning at breakfast this morning, a supermarket chain came to me and said, we need to move from only touching our customers at the checkout once they've already made all their purchase decisions to moving to interact with them actually before they even enter our store. So we want to set up a system where we can combine information that our customers are willing to share with us from the devices that they carry around in their pocket that signals their location with real-time sensors that we have in our supermarket. We're going to put infrared cameras so we can tell how long people are standing in front of the milk counter. And we want to take those information in real time and combine that into a different experience of shopping, so that as you walk down the aisle, you will be receiving offers and coupons personalized to you where you are at that point in time in the context of what you're doing. And this type of real-time analytics is going to define this new era. It needs new development paradigms, it needs new data fabrics, and it, above all, needs us to be able to run our existing operations more efficiently so we can free up the funds to confront this challenge. So a lot of what I'm going to talk about today is first of all, how do we reduce operational spend on existing applications and infrastructure? Very tough thing to do because we have enormous amounts invested in these applications. We cannot walk away from them. We're going to have to continue to run them for a very long time. And precisely because we can't rewrite them, a lot of the innovation is going to have to occur underneath the applications, down in the infrastructure. So what we can do is take these existing applications and move them onto a modernized infrastructure, which will allow us to take operational cost out of running them, which is very important because, as you well know, for every dollar spent in IT on equipment, depending whose numbers you want to believe, $4 to $8 are spent on basically operating it. So if we can take existing applications and start to get higher levels of operational efficiency, that was what will allow us to free up the funds to tackle the next generation of canonical applications will define this new era. And many of us, our challenge is to figure out how to navigate this path. How do we strike the right balance between achieving operational efficiency in our existing world and redirecting the spend towards the new world? So we like to think of this as what's really this is going to cause is 3 levels of change inside the IT industry. The first level of change starts with existing apps and existing data centers and basically says, how do we perform infrastructure transformation that allows the existing apps and existing equipment to be more efficiently used and opens up the opportunity to go to other models of paying for that infrastructure, to being able to go to shared services in particular, where we can drive the infrastructure to even higher levels of utilization and thereby achieve cost. And this has to be done down at the plumbing level, because if we were to say that the only way we can do this is by rewriting every application in the world, that's a non-starter. So we need to look for those applications in our existing inventory that can be put on this journey. We then need to realize that the next step comes really in terms of application transformation, and this is where real mission-critical value is achieved. There's only so much you can do by improving the plumbing. Ultimately, you have to get into the application space because that is where value is encoded. Now, if this wasn't complex enough, we're going through another transformation in our industry, which is very challenging for IT. It also holds tremendous opportunities, which is that our industry had lived through the last 10 or 15 years and sort of got good at managing Windows-based laptops. We're not great at it, but we sort of figured out how to do that. And no sooner had we sort of figured out how to do that, but new animals have come into the zoo. And they've come in uninvited. In many ways, it reminds me of personal computers coming into the IT industry in the late 80s and early 90s. They came in uninvited in spite of IT, and we see the same thing happening now. iPads, smartphones, etc., are coming into the enterprise environment uninvited. And just as in the PC era, IT is ultimately going to be left holding the bag behind this. Because it is IT's responsibility at the end of the day to securely deliver capabilities in a compliant way to the customers of the enterprise. I had one CEO say to me, he says, I only ask 2 things of my CIO. He says, I want newer and better applications, and I want my name out of the paper. And those are really the jobs of IT. And the days when IT could say, we know that every individual in our domain has a black laptop with exactly this build of Windows on it, is rapidly passing. And they know that they're never going to get it back. That the devices users will hold in their hands will largely not be under their control, and not only not under their control, but actually not even owned by the enterprise. Tremendous challenge for us in the industry, which is how do we deliver the fruits of all these applications in a secure way where the endpoint itself is becoming much more heterogeneous and less under the control of the CIO. this is going to be an important issue for us to address in the industry as we go forward, which we think, for a couple of reasons that I'll outline as well, is going to lead us into a new era of end-user computing. I agree with Steve Jobs when he says we are entering the post-PC era, and that is actually also very profound and has a lot of implications that I'll touch on towards the end of my presentation. So how do you go then on an infrastructure transformation journey? The simplistic view of this is that in order to start taking existing applications on a journey, you basically have to jack them up and slide new infrastructure underneath them. That is what is called virtualization. The next step beyond that is to start using that infrastructure in a more informed and business-like manner, which is sometimes puts the label cloud next to it. So let me just try and explain what I mean by those two steps. Virtualization at this point is a well-accepted technique. Primarily, people justify it on hardware consolidation. Through the efforts of myself and others at Microsoft in the 1990s, we unleashed this client-server revolution on the world, where we resulted in having tens of millions of servers that were idling along at a mere fraction of their capacity. You know, typically well less than 20% CPU utilization rates. And people figured out that they could use virtualization to collapse those servers to fewer servers, drive them to higher levels of CPU utilization. Very short payback, very effective thing to do. But there was actually something more important going on, because when you virtualize, what you're essentially doing is taking an existing application and a lot of the complexity around it, the middleware, the operating system, etc., and putting it into a black box. You're encapsulating it. And when you encapsulate, that's when you can jack that application up and slide new things underneath it. You start cutting the tentacles of complexity, those stovepipes that make the current IT environment so rigid and complex. And not only can you jack the application up, slide new functionality in it, but with modern technology and the very fast processes we have now, you can actually slide that application around in real time. You can move it in real time without missing a beat from one physical server to another, which has a lot of implications initially just by making your environment easier to manage. But it sets up the next key step, which I'll come to in a second. As I said, this is a well-accepted technique in the industry now. These are IDC numbers you hear. And if you count up the number of server workloads running on Intel processors, according to IDC, we have just crossed the threshold in the industry where more than half of the server applications in the world are now running inside these black boxes in a virtualized environment. So what that means is some interesting things. First of all, it means that we have those applications running on virtualized environments, but it means that the operating system sitting inside those black boxes, whether it be Linux or Windows, actually no longer see the hardware. They're just seeing some idealized version of the hardware that's being presented up to them. The real job of coordinating the underlying hardware has been taken over by another layer. And that's why people, in many cases, talk about virtualization as the first step towards a data center or cloud operating system, because operating systems, as you know, did two things. They coordinated hardware on the one hand, and they provided abstracted services to applications on the other. As you'll see in a moment, both of these functions of the traditional operating system have been taken over by new layers, by a new layer being slid underneath it, and you'll see in a moment by a new layer being slid on top of them, which is why the traditional operating system is no longer the focus of innovation in the industry. Now, this is a statement across the industry. In our federal government, the numbers are considerably lower than this. Our best guess is, if you take a generous look at the federal government, you're probably at about the 20%, 15 to 20% level, which means that there's tremendous opportunity here basically to see savings by pushing this technique further. And often this is the best way to get applications set up to be able to take advantage of the next step along the journey. Because once you've done that, what we can really then do, given that we can now slide applications around in real time across physical processes, is we can now start aggregating the hardware together to create the illusion of a single giant computer. I mentioned earlier that I'm old enough to have started my career in the mainframe era. So sometimes when I want to be slightly facetious, I say, and I'm talking to people over the age of 45, I say, look, this cloud, it's just a software mainframe. That's what we're trying to do here. Of course, if I'm talking to people younger than that, I call it the cloud because it sounds much more sexy. But it is basically this idea of being able to aggregate and pool resources together. And when you get a bigger pool, you can use the pool more efficiently. The bigger the set of resources you have to schedule over, the more efficiently you can use those resources because you can smooth out peaks and valleys. We have one of our service provider partners who's using this technology to bill for services in a different way. Instead of the normal model in the cloud, which is where you rent a virtual machine by the hour, what they will do is rent you a pool of capacity. So they'll rent you so many gigahertz of CPU, so much memory, disk, etc. And just like the cell phone companies, if you happen to momentarily exceed your threshold, they don't cut you off, they just charge you an extortionate rate for the time that you're over. And they found that very interesting, is when people first come into that model, they dramatically over-provision because we're so used to provisioning to the theoretical maximum. In IT, as you'll see in a moment, we really don't have good metrics, which means that we really don't manage it well, which means that we are similar in the position of engineers were 100 years ago. When we build a bridge, we just build it as 10 times as strong as it could conceivably be. And as a result, we are making very inefficient use of our underlying infrastructure. And if you start to get information, then you can use it more efficiently. So people come into this environment, they literally over-provision CPU by a factor of 10 initially. But the important thing is they can now get information about how much CPU across all their applications that they're actually using on a minute-by-minute basis on average through the year. And gradually they start getting comfortable and they start bringing that threshold down and down and down. So when you move to this approach, you can not only pool to get greater efficiency, but you can now start to get better metrics out. You start to get information across a collection of applications. It's the next benefit from not operating in a stovepipe manner. And when you get better information, as you'll see in a moment, you can manage it more effectively. And that then allows you to spread the expense over a group of tenants. People can benefit from the shared efficiencies that they're starting to get. And a lot of this is going to requires changing the way that we account for IT inside enterprises. Today, there are not many incentives for any particular unit inside an enterprise to become more efficient because IT is simply taxed as a 1 or 1.5%, 2% tax right off the top line. And as you know, when everybody's being taxed, nobody has an individual incentive to become more efficient. When you start to be able to connect cause and effect, who's actually consuming the infrastructure, then you can start incenting a lot of the right behaviors. So with this technique, we can extend this further to not only pulling together infrastructure inside a data center, but also actually start to span across data centers. And this enables a model which is being called in the industry the hybrid cloud. In other words, how do we get a pool of infrastructure that might be under the particular control of one organization and combine it with infrastructure that is being provided by another organization? Sometimes that's called the external cloud. It just could be another pool of infrastructure somewhere else that you have the rights to access. Now, this only works if we can get these pools of infrastructure connected by common management and security. Because if the way that we secure and management and applications inside one pool is radically different from the way you do it inside another pool, you can't just slide those applications backwards and forwards as you would want to. So if we can get the management security layers common, then we can start to slide applications backwards and forwards between data centers. And this turns out to be very useful for a number of reasons. Not only do you now have the option of tapping into other pools, potentially renting them, etc., but even without that, it's very important and useful for basically doing, for instance, data center migrations. We now saw enterprises where they do a data center migration by essentially setting up the new data center, establishing a connection between the two, and then simulating a disaster by cutting off the original data center. Everything fails over onto the new data center, and basically they continue running forward in that way, as opposed to the traditional way of doing this incrementally over a long period of time. It's also very important, used by folks in the DoD for remote deployment. Set up an infrastructure, get it all running on one data center, move the equipment into a forward deployment, and then snap everything over onto the forward deployed infrastructure. Obviously, this is very important for disaster recovery, and is actually what's driving a lot of change inside the enterprise. We had a great example of this with a German customer of ours, TUV Rhineland, who's in the chemicals business. They had a chemicals plant in the Fukushima area of Japan, which got taken out in the tsunami. Because they had a data center recovery plan in place, they were able to fail back over to their main data center in Germany, and basically within less than a space of an hour, we're back up and running. This is what businesses are increasingly trying to think about, which is how do we make sure that we are resilient under load? And when you start to encapsulate your applications, cut the tentacles of complexity, that's what allows you now to make those applications more mobile in a certain sense and take advantage of increased infrastructure utilization as well as increased resiliency. Now, as we move to this cloud-like way of operating, where we're going from the stovepipe world to a pooled infrastructure world, certain things have to change. One of those is how we handle edge security functions. As you know, no application is really purely the application code. An application really is the combination of the application code and a set of edge functions that surround that application, a firewall that's protecting it, a load balancer that's distributing the load amongst the modules of the application, a data loss prevention engine that's watching the information go in and out, an antivirus engine. These are all really edge functions that get associated with an application today. So when you really provision an application, you're not only setting up the application, but you're placing strategically these edge functions. Today, these edge functions are largely physical boxes that get clamped onto wires. So you literally find the wire that's carrying the packets into that application, and you clamp one of these devices onto that wire. In a world where we're going to take those applications and for efficiency reasons as well as resiliency reasons, move them around in a pool, those edge functions now have to themselves become virtualized and move with the application. So we have to take functions that are today placed on physical boundaries and move those to being placed on logical boundaries. And as the logical boundary is what stays constant, the physical boundaries move, so the protective functions have to move appropriately. So this is one of the key things that starts to change in this new world. The good news here is there are actually many more logical boundaries than there are physical boundaries. So when you start to associate protective edge functions with logical boundaries, you can actually get much greater defense in depth. In this world, you'll be able to say, we have a policy in our environment that a database will never get deployed without having a dedicated firewall in front of it to protect against SQL injection attacks. We'll go from the situation today where if a bad guy can get past the fundamental physical perimeter around the data center, they're in the candy store because they can then reach out and basically poke anything that they can possibly see. By going to logical boundaries, we can get well-known military concept defense in depth here, much more easily, much more cost-effectively, much easier to administer. The other interesting thing that has to change is how we do management and monitoring. When you go to this pooled approach, you're going to have some guy or persons who are the custodian of the underlying pool. And their job is going to be to look at that big pool of resources you've created and be able to know whether that pool is fundamentally healthy or not. They're not going to know a lot about the applications on top of that. In fact, they have to know less and less, because if we have dependencies down onto the underlying infrastructure, we'll never get the degree of flexibility and pooling that we need. What's more is those pools will get so big that the amount of information, if you turned on all the logging capabilities in the pool that it would throw at you, will just dwarf and overwhelm any individual. So we have to go to a different way of doing this. So what you see is the industry, ourselves included now, starting to actually bring to market one of the first examples of a real-time analytic information, which is where we set essentially a system to watch the infrastructure that just says, give me all the information you've got. Don't try and figure out which information is important or not. I'll figure that out. It runs it through a sophisticated statistical analysis to build a model of that infrastructure, and then sits there watching the infrastructure and says, with reference to this model, are things normal or not? Every now and then it'll put up its head and say, we just think you went outside the bounds of normal. Now, this is a statistical model, so you will get false positives every now and then. Every now and then it'll put up its head and say things are abnormal, and you can say, no, that's just the end of the month. Don't worry about it. And it will learn from that and not bother you about that particular situation again. But the interesting thing is these models tend to be much more sensitive to humans to change. We often do a great demonstration where we'll go to a customer and say, look, tell us the last time you had a bad thing happen and give us a month of log data before that. And we take that log data, we run it through our analysis, and typically days, sometimes a week before the event, we will start to say to them, this is where things started to go wrong. This is where we could have given you a warning about what was going to happen here. And this is an example of what I mean by real-time analytics being applied in the context of infrastructure itself. Application monitoring is going to have to be done within the application itself. We're no longer going to be able to reach down into the infrastructure and do our instrumentation and introspection there, which means that we have to find new ways within the application of doing the instrumentation and introspection. A very important topic that I'll touch on briefly when it comes to security in a moment. And that's one of the reasons why, for those of you who are technically inclined, why we think these new programming frameworks are so important, because they provide the logical place to do introspection and instrumentation in the application space going forward. Now I want to just take a step backwards from the technology and talk about why this approach to computing matters from a business perspective. I started my working career in the United States in 1981 at Intel, working for Gordon Moore and Andy Grove and Bob Noyce. And Andy used to drum into us this saying that if you can't measure it, you can't manage it. And unfortunately, we in IT only have very coarse metrics today to manage IT. If you're the CEO, basically today, you really have two decisions you can make about IT. What % of my revenue do I want to spend on IT? And do I want to entrust it to the bunch of guys that I have? Or do I want to outsource it and give it to a bunch of different guys? Really, that's what a CEO can do with IT today, and it's not a very satisfying world to be in, as you can talk to any CEO and they'll tell you that. And part is we don't have objective measures that allow us to shine a light under the hedge and find out how we are really doing in the IT world. Now with this cloud era, we're starting for the first time to get blunt but effective measures of IT. For the first time now, you can go and say to your IT department, Mr. CIO, what does it cost us to provision a virtual machine of a certain size per unit time? Tell me what the answer is. And don't give me anything else. Just tell me what it costs you in cents per minute. Tell me, Mr. CIO, what it costs you in cents per gigabyte per month to store information. Tell me what it costs you to support an email box. Tell me how quickly you can stand up a new service. And you can take those numbers and start for the first time to compare them to an external rate card. For the first time, you as a CEO or a CFO can take numbers from your CIO and go compare them to a price list that Amazon and others are establishing. And you can say, why is it, Mr. CIO, when you're telling me it's costing us 15 cents per virtual machine per hour and XYZ down the road is willing to sell that to me for 5 cents per hour? Now, in many cases, there are good reasons why that's not the case. There might be higher levels of security involved, regulatory constraints, all sorts of things. He doesn't have as big a pool to amortize over. But for the first time, you can have a meaningful discussion about that. You can say, if this is the reason why we are that much more expensive, reasons 1, 2, and 3, are those reasons really that important for us? They might very well be. But one of the things that we know is when you start to measure things, it leads to increased efficiency. And it's wrong just to point a finger at IT here, the production side. We need to also hold up the consumption side of IT to the same scrutiny. Because just as there's a lot of ill-informed production of IT, there's as much or even more ill-informed consumption of IT. People just don't know what it's costing them to basically consume certain services. And what we need to set up is a much more meaningful dialogue between producer and consumer so that we can establish benchmarks and priorities to pull ourselves up in terms of this fundamental efficiency that we're going to need to free up the funds to invest in the future. So while these techniques make sense from a technology point of view, they make just as much sense from a business point of view. I'm going to run through very quickly the rest of my presentation. The journey we've seen typically plays out in 3 phases. It comes through initially IT, because IT are by and large technically savvy and smart. They then run into a barrier when they try to really go after truly mission-critical systems, where the owners of the mission-critical systems say, hey, from my perspective, it ain't broke, so don't fix it, thank you. Often it's a disaster that gets them through this phase, where something will collapse, IT will temporarily rebuild them on the new infrastructure. They find out that the world doesn't end, and they say, look, if you could rebuild me that quickly on this new infrastructure, why are you telling me it's going to take 3 months to get these other things I want done? And then IT says, well, that's because you wouldn't let me virtualize. And so they say, oh, okay, well, let's go do that. But at the end of the day, it comes down to leadership. To take it all the way through to basically operating in a more informed way, it takes leadership. The third phase is when the CIO takes ownership of this and says, we're going to use these techniques to run ourselves in a fundamentally different way. We're going to measure the production and consumption of IT and use that measurement to drive efficiency both through ourselves and put a lot of the onus back into our customers to establish priorities for us. I want to touch briefly on application transformation. There are 3 key forces that are operating here. One is new frameworks, the other is new data fabrics, and lastly is new ways of provisioning both applications and data. The new programming frameworks, as I said, come out of a developer-led revolt against complexity. It's interesting for me, who's been working in platforms and software technology over 30 years, that just as when we thought that the world had kind of settled down around EJB and .NET 7, 8 years ago, we didn't realize that there was a revolution brewing under our feet, led by younger programmers working largely in the open source community who said, we don't have time in our lives to deal with the complexity that you created for us, thank you. We're going to put in place frameworks that hide a lot of that complexity. And you see tremendous innovation in that space now, whether it being in the Spring community, which has its roots in the Java world, the Rails and Sinatra communities, which have their roots in the Ruby world, now Node.js, which has its roots in the JavaScript world. And for an old mainframe programmer like myself, this makes my head hurt because if you're in the generation that lovingly like to count expended instructions and try and find more efficient ways of doing it, I can tell you, just look at the Ruby programming language. They didn't miss a single trick to make it impossible to get efficiency. They hit every one of them. It's impossible to compile, impossible to optimize. And then suddenly you realize what they were trying to do. They're saying the real asset is us, not the machine. We need to optimize ourselves. Let the machine sweat. Who cares if we expend all these instructions? That's what the silicon is there to do. And a fundamental inversion of priorities. This is going to be important, as I said, for security in the future, because one theme that I'll briefly touch on is security starts at the perimeter, but it has to successively move closer and closer and closer to the applications, because every time you set up a barrier, people figure out a way to get over that barrier, and then they start to attack the next barrier. Ultimately, security is going to have to go right inside the application itself. You're not going to be able to trust other modules that you're talking to. We're going to have to move to a world of trust, but verify at every level of abstraction, ultimately reaching right into the applications itself. And these programming frameworks provide a way, and they have some very sophisticated techniques, where you can introduce code into an application written by a separate team from the application logic coders that will sit there and basically monitor what's going on in a non-obtrusive way. And these are the kind of techniques that we're going to have to adopt to get ultimate security. I often worry about the fact that all of us employ large armies of programmers. The weakest link in any chain is always the human. Who knows how many of those programmers may or may not have your best interests at heart? How do we defend ourselves in a world like that? So these are part of the techniques that we're going to have to, the toolbox of techniques that we're going to have to reach for in the future. New data fabrics are emerging. As I said, there are applications now that cannot be done on relational databases. You have to, in order to get sufficient bandwidth between the program and the data source, distribute it out. Otherwise, just the bus bandwidth leading to the data store becomes a problem. So you need to have multiple buses that can carry the traffic between the application and the data. A good example of this actually is a data fabric, which I'll admit is one that we acquired 18 months ago, called GemFire, that sits underneath an application used by many of you, I presume, in this room to track real-time assets, both friendly and hostile, in theaters around the world. This is a system apparently that has to receive 60,000 updates a second. Visa credit card system receives 2,000 updates a second. This is operating at an order of magnitude greater scale than the world's biggest credit card system. This could not be done on a relational database. This application was developed using the GemFire technology, which is a distributed in-memory database by Northrop Grumman. They looked at many approaches and concluded that the demands of this application were such that they had to go to a new data fabric. When you go to a new data fabric, that drags everything with it. This is the thing that will really take us into the next generation, new types of development techniques and infrastructure. We need different ways of connecting applications to the underlying infrastructure. Our industry came up two or three decades ago now with Linux/Unix as a cloaking layer to hide the underlying hardware, to make it easier to make sure that when you wrote applications, you could amortize that cost across different instruction sets and different computer systems. Now, clouds are becoming the new hardware. Are we going to move to a world where these clouds become like the mainframes of the 60s and 70s, where when you write an application in that space, you can never move out of that cloud? If you write for Google's cloud or Microsoft's cloud or whatever, are you condemned forever to be hosted in that cloud? We believe that the open source community and the development community will not stand for that ultimately, and a new cloaking layer will come about. So we have invested, and those smart guys from Google I mentioned earlier, we put a couple of years ago onto developing what we think is the new operating system that will cloak infrastructure-level clouds and can be deployed across multiple heterogeneous clouds and will give you that level of portability across clouds. And because we believe that this has to be fundamentally open, we have contributed this effort to the industry under an open source Apache 2 license. And we've recently introduced it, have about 30,000 developers signed up using it today, and our goal is to see that thing go onto every possible cloud that it can sit on, internal or external. So this is a cloud. In fact, we will be releasing a version shortly that can sit on a single laptop. So a developer can have his own cloud on his or her laptop, develop his applications on it, and then push it into a deployment cloud, whether that be an internal cloud or an external cloud. Lastly, I want to touch very briefly on the end-user computing transformation. Again, a lengthy topic here, so I'll just touch it at a very high level. The challenge here is we need to go beyond the desktop. The Windows desktop in enterprises served two functions to date. On the one hand, it was the user interface to a particular operating system. On the other hand, it was the conduit or mechanism by which IT prescribed what capabilities a user could see. That's where you installed applications, where you turned on and off menus, you dropped files there, etc. It was the portal or the container that you created for the user that held basically the set of capabilities and resources that that user could legitimately access. That second usage of the desktop has to get floated away from any particular device or operating system. We need to find a new mechanism whereby we can essentially, instead of installing applications to devices, install applications and information to users and have that collection of capabilities appropriately manifest on whatever device that user happens to touch at that point in time, and they're going to touch multiple of them in the course of the day. So this is a big challenge and paradigm inversion for our industry as well. Beyond that, we have to go beyond documents. I'll mention in a second just what I mean by that. So in this new world, we need a new desktop for provisioning and security that belongs to the user, not to a particular device. Again, it has to provide a bridge from the past to the future. We can't walk away from the long tail of Windows legacy applications, but we have to realize that new applications, by and large, are going to be written in the HTML5 world. This will be the new API that applications get written to in a device-independent way. And we need to bring both of those worlds together and provision them through this new, quote-unquote, desktop. Lastly is we need a new generation of collaboration tools. I mentioned earlier that I got sidetracked at the beginning of my career, taken into the microprocessor world. Instead of becoming a mainframe god, I started out at the bottom with Intel, and then was lucky enough to get involved with the whole PC business. And the first 20 years of my career were contributing to a big endeavor that started at Xerox PARC in the late 70s, carried on by Apple and Microsoft, which was essentially to automate a white-collar worker circa 1975. So we looked at a white-collar worker sitting behind his desk, or her desk, and they had a desktop and they had drawers with folders in them, and they had an inbox and an outbox, etc. And we looked at all those paradigms and we said, how do we automate that? And it was an incredibly successful journey. The industry went on that, and by and large, we achieved that goal of automating the activities of a white-collar worker circa 1975. And white-collar workers at that time basically most of the time preparing documents. They had a few tens or hundreds of documents that they worked with that they lovingly tended to. The highest goal was to get it to print with perfect fidelity, etc. That's what not the new generation of white-collar workers do anymore. They don't sit in front of desktops. They don't lovingly tend to documents. Instead, they consume streams of information that are coming to them. The challenge is to help them filter those streams, comment on them, recombine them, and stream that information back out to other people who can make use of the value that they've had. This is a huge transition. So as much as we talk about the post-PC era, I think this is really about the post-document era. So the next decade are going to be about redefining the paradigm of what an information worker does in terms of how they consume and manipulate information. So another set of interesting challenges that all fit under this C word, the cloud. Lastly, I'm going to touch very briefly on security. This is obviously a very complex topic. We see two things or three things going on here. One is we see a migration of edge and perimeter checks going from physical boundaries to logical boundaries as we move into this world. And there are more boundaries, and a lot of those checks are getting more sophisticated. It's no longer simply about who's trying to access what resource and do we admit that access or not, because we can't live in ultimately completely isolated worlds. We have to let information flow, which means that we have to move security from being purely perimeter check-based to essentially becoming more and more behavioral. We have to look at what's going on and make judgments about what's happening. Security is becoming much more like what the financial industry does in terms of credit scoring and fraud detection. When you log on to your bank's website today, the fact that you've got your credentials right just means that you've got table stakes at that point in time. They just allowed you to come and play, and they're going to look at everything you're doing at that point onwards. They're going to look at where your IP address is. They're going to look at basically how you're navigating their web pages. Are you going through that web page in an unusual way? And they are in real time, another example of real-time analytics, constantly scoring you against a model of normality. And the moment you deviate from that model of normality, they will take some action. I grew up in South Africa, so I happen to go back there. If you ever want an example of this in real life, go and get a bank account at the South African bank. In the midst of being online, suddenly they will freeze and say, we're worried. We're going to send you an SMS to your cell phone. And before you can continue, we want you to respond to that SMS because we've seen an unusual pattern of activity. You haven't gone through your account in exactly the way that you normally do it. It's this kind of behavioral analysis that we're going to have to move through. So security has to go from being purely a perimeter-based thing to behavioral monitoring. But at the end of the day, and this is a sad fact that us in industry are realizing, is that whatever you do in technology, the weak link is the human. And security ultimately has to become a way of life. Just as we've learned to take off our shoes in airports, we in industry are going to have to educate our users to take off their shoes every time they access our computer systems. And it's a big cultural challenge for us, quite frankly. Trying to educate my programmers who love to have free and unfettered access to everything, that their source code is unfortunately of high interest to a lot of unsavory characters in the world. And as a result, we're going to have to take off our shoes every time we access the source code server. It is a tough cultural transition that we're putting our groups through. And for the first time, I think industry is really having to confront security as a fundamental issue. And it is not just about technology, it's about how we educate and incent our people to behave. So a lot of areas in this, both the edge checks and the behavioral monitoring have to get closer and closer to where the real value, which is inside the application. Much longer story, but a very important one. That brings me to the end of my presentation. I'll just mention in passing that our company, my company, VMware, is trying to invest in each of these three transitions, trying to figure out where this is going and place our bets accordingly. I won't spend time going through these products, but we do have entries at each of these levels. And we're committed to providing those to all branches of government. I'm very happy to say that our products are in use essentially by all parts of the federal government, and we're very proud to do that. As I mentioned, am an immigrant to this country. I showed up here in 1981 with a wife and a 9-month-old baby and not much else, and have had just been extraordinarily fortunate and benefited from everything we have in this country. I want to just personally thank all of you who have chosen a career of service to protect all of that for other people who can have those benefits. And I'm happy to say that I try to pass that ethic on to my own children, and I have 2 daughters who have both chosen in their own way to serve their country, one through the Peace Corps and the other through Teach for America. So thank you very much. We have time for a couple of questions, and there are some microphones, so if there are any, I'd be happy to do my best to field them. And of course, I'm always in the market for free advice as well. So.
Yes, sir. This is Jerry Robbins from Northrop Grumman. It strikes me that we're moving so far and so fast in technology, and Mr. Chambers came in and talked about what they're doing at Cisco. You're talking about VMware. It also strikes me that we have so much information coming in right now. How do we as human beings process this? You talked about the filtering. What do we know to filter? How do we use what we get? Do we miss anything? Could you comment on those kind of activities?
Well, this is, I think, both a challenge and an opportunity going forward. And I don't have a simple answer to that other than we have to build systems that are able to combine both static and dynamic information. So we have to have systems that can look over historical data, build some kind of model of reality, and then as real-time information comes in, basically adjust that view of reality and assist people to make decisions. So this whole next era of computing over the next decade or more is going to be characterized by systems that assist with real-time decision-making. You can start to see canonical versions of those starting to emerge. I mentioned one in the infrastructure monitoring space, which is specifically about how do we assist system administrators who have to deal with this torrent of information now, be able to make filter out essentially the unimportant stuff, construct a model for them, and give them information about when that model is changing. That's where we're going to have to go. And a lot of it is how do we, as I said, make that transition from a non-real-time world we are today towards a real-time world. I'm convinced that when you have such a demand, it will get fulfilled. Every era, we've seen new companies rise to take advantage of that. Typically, it hasn't been the existing companies that have done that. Particularly every time the data fabric changes, you see new companies come into existence. So as much as I worry about my existing competitors, I worry about the company I don't know about, because there are young people really thinking deeply about these problems. And a lot of it comes, as I said, out of the consumer space, where they're trying to model in real time human behavior and react to that. So not a very precise, but it is a direction that I think that the IT industry is going to have to respond. You want to go to that mic there?
Good morning, sir. Commander Jamie Guiteau from U.S. European Command. Throughout your presentation, you kept showing the little icon that showed the app sitting on an OS/middleware layer that was sitting on the cloud layer, et cetera. One of the biggest problems that I see is the hundreds and hundreds of nearly identical copies of an operating system that's not value added to that whole process chain. When do we move away from that? When do we containerize applications to allow them to run directly on a distributed cloud operating system without having to eat all that overhead for every single one of the devices?
Well, what I see really happening is two things playing out. One is where people just don't want to touch the application no matter what. So in that case, virtualization helps, because you can essentially mask the fact that there are multiple different copies of the operating system, because you put it inside that black box and hide that complexity to a certain degree. The other thing that's playing out is that as people move towards these new modern programming frameworks, They're realizing they need less and less of the operating system. If you're writing, for instance, in the Ruby on Rails programming framework, there is an operating system involved, and if you work damn hard, you can find out which version it is, but it's completely uninteresting. Operating systems are going to shrink to kind of an important but fundamentally uninteresting piece of middleware that's hidden down in the gut somewhere. So people are, and this is one of the reasons why approaches like Linux really have an advantage here, because it's easy to peel pieces off them and throw away the pieces you don't need. You don't need, all 140 million lines of a legacy operating system there sitting there, as a security target if all you wanted was memory management. So let's throw out all the other pieces and just keep that piece there or whatever it is. So I think you're going to see the traditional operating system shrink and fade into the woodwork, thankfully. It's bittersweet for myself, having spent most of my life trying to build